Okay, so now that we know that an EEG allows us to distinguish between the different brainwave patterns that our brain is going to go through over the course of a night, we can talk about what some of those patterns look like. And so first, let's define what sleep is. It is our periodic, because it does happen pretty regularly, natural loss of consciousness. So you haven't been knocked over the head. It's not like you're experiencing something really abnormal. It's completely natural for you to lose consciousness every single night. And so this is distinct from things like coma, which comas don't seem to go in a 24-hour cycle, general anesthesia, so that would be artificially physiologically induced, or hibernation, which humans don't seem to undergo. As the really quick flashback to being in a coma, hopefully you should remember what part of your brain, if you were missing it, would cause you to slip into a coma. And if not, go review your notes on different parts of the brain, specifically parts of the brain stem. Okay, so here we have a chart which is showing us our typical sleep cycles. And what you can see is that we generally are supposed to get around 8 hours of sleep. And so that's why these cycles are going to last 8 hours. And you can see immediately from this chart that as we go through our entire night's sleep, we're going to be going through the same stages multiple times. And that's very, very typical. We tend to go through a complete sleep cycle about every hour and a half. So by the end of a night's sleep, you should have gone through approximately 4 to 5 of these cycles. And so we're going to go through what all of the different stages are, all the way from stage 1 down to stage 4, 5, and then REM stage. In order to go through all the different stages and distinguish between them, we have to know how our brain is responding and how our brain is acting during the different stages, because neural activity is actually what's going to characterize our different sleep stages. So you can see here in this image of brainwave patterns, all sorts of different options for how our brain might be behaving. And we're specifically going to be focusing on these alpha waves as well as these delta waves. Because at different stages of sleep, those waves in particular are going to be seen. Okay, so first we'll start with this stage of our sleep cycle, which is the awake stage. During the awake stage, as you're starting to drift off into sleep, your brain starts to produce alpha waves. And so I remember alpha waves as when you're awake because they both start with an A. And if we look back at our image here, alpha waves are going to be a very, very relaxed brain state. Obviously, there's more brain activity during an alpha wave stage than during a delta wave stage. But your brain starts to sort of slow down. You can see it's more of a rolling wave than when your brain is like awake and alert, as opposed to awake but drifting off to sleep. And so you transition from this sort of awake state where your brain's producing alpha waves into stage 1. And stage 1, neurally, is marked by irregular brainwave patterns. They don't fall into some sort of rhythmic alpha or delta wave yet, because this is just our first stage of sleep. You can definitely hear a transition in terms of your respiration. People's breathing slows down in stage 1. It becomes very rhythmic. Some people in stage 1 will experience hallucinations. You might not realize they're hallucinations. They're more specifically called hypnagogic sensations. But you know that feeling you get as you're sort of you feel you're asleep and then you jerk awake because you felt like you just maybe like fell off a cliff, or you feel that like falling sensation. That's a hypnagogic sensation. It's actually hallucination. Your brain is giving you that false sensory sensation of falling when you're not actually falling. And stage 1 tends to be very, very brief. We move from stage 1 into stage 2 if all goes as planned. You can be woken up pretty easily in stage 1, so sometimes there's a lot of stage 1, back to alpha, then back to stage 1. But when you enter into stage 2, you spend about 20 minutes here. And what your brain is doing during stage 2 is it's sort of, chilling, and then it gets very, very, very active, and it shows what we call sleep spindles, and then it just sort of flatlines again, and then sleep spindles. And so during stage 2, for that 20 minutes or so, you have these bursts of brain activity. And you can see here a sleep spindle is being represented. From stage 2, we move to stage 3, so you can see we're going in order. And stage 3 is really just a transitional stage, only lasts a couple of minutes, and it exists to get you to stage 4, where we're now going to descend into really, really deep sleep. That's the way that our sleep stages work. It's sort of, we go deeper and deeper and deeper and deeper and deeper into sleep. It becomes more difficult to wake people up, for example. And so in stage 4, your brain is emitting delta waves. And so if we go back to this image here, we can see our delta waves right here are going to be really, really, really slow and meandering because delta waves are going to be happening when we're in really deep sleep. So delta starts with DE, as does the word deep, because that's when delta waves are going to be happening. And stage 4, really, really deep sleep, is going to last for about 30 minutes. A fair amount of sleep problems can sometimes be associated with stage 4, which we'll talk about in a second. But we transition out of stage 4 into the most commonly talked about stage of sleep, which is going to be the REM stage. REM is an acronym. It stands for Rapid Eye Movement. And you can tell someone's in REM because their eyes are literally moving really, really, really rapidly. Sometimes people's eyes are closed, but you can see their eyeballs like flickering back and forth very, very, very quickly, and that's where it gets its name REM. But what you also want to remind yourself is this is where dreaming is going to occur. And if you look at the word dream, it has REM right in there. And we get to REM because we're going to actually sort of put a reverse on from stage 4, and we're going to transition back up to the REM stage. And REM stage is sometimes called paradoxical sleep, and it's called paradoxical sleep because your body is exhibiting sort of paradoxical effects where you have a flurry of activity in some areas. Your eyes are moving like crazy. Your brain is really, really active because you have all of these dreams that are occurring. Your breathing can become really rapid, very, very irregular. So you have, on the one hand, a flurry of activity, but then your body is completely paralyzed during the REM stage. And so therein lies the paradox. You have so much activity, but then your body, most of your body, at least from the neck down, is completely paralyzed. And this paralysis is on purpose. It seems to serve a protective function because your brain is so active during this stage. What your brain does is it paralyzes the rest of your body. Think of how dangerous it would be if you tried to actually act out all of your dreams. You'd go around, punching people and running out of your bed, and you'd fall and you'd really hurt yourself or somebody else. And so your body accounts for this, and it actually stops any motor messages from getting to the rest of your body. So from the neck up, there's all sorts of activity, but from the neck down, you are completely paralyzed. And some of y'all might experience lingering effects of REM paralysis in something known as sleep paralysis, which we'll learn about when we do sleep disorders. All right, so we've gone through the basic sleep stages, but what we've done is we've only really talked about one cycle of all of these sleep stages. And as you know, we go through around 4 to 5 cycles a night, but each cycle is not identical. What happens as the cycles progress is you descend into the cycles, and you hit stage 4, and then you transition to the 5th stage, which is actually REM stage, which is sort of a step back up, and you climb your way back out of the sleep stage to start the whole process again. And so one of the trends that we notice as the night progresses is you spend less and less and less time in that really, really deep sleep of stage 4, but more time in the REM stage. And both stage 4 and REM are very important for different reasons. During that really deep sleep, it seems to be a restorative time for your body and for your brain. The REM stage is when all of your memories are getting consolidated and your hippocampus is really, really active. But as you get closer to morning and you're reaching sort of that 6, 7, 8 hour mark of being in sleep, we're going to be spending way more time, the majority of our time actually in the REM stage. And as kind of just a last note before we end this video, there's been sort of a new trend with the advent of smartphones to be able to track your sleep. Some of you guys might even have like fitness trackers that you wear, like maybe on like a Fitbit maybe or Fitbit Flex. But you can also just use your smartphone and track your progress through all of these different sleep stages. Sometimes they're called things like smart alarm, for example. And what it'll do is it actually will show you how you go through all of your different sleep stages over the course of a night. So it's kind of a really cool thing to maybe try just for even a couple of days to see that you also cycle through these periods of somewhat wakefulness and then deep sleep and then back up again to something more wakeful. And the way that these apps are actually able to work is because of the fact that you are so still during some stages of sleep. Even, for example, during REM, your body is paralyzed. And then as you transition back up to like the stage 2 area, stage 1, you're going to start to maybe toss and turn a little bit, and then you calm down again, and you're there for, you know, the next hour or so, and then you go back up. And so the app is aware of that, and it actually, your phone sits next to you on your bed. And it can measure using its accelerometer the movement of your body.